Alright, so question 43. It says, if x and y are positive integers such that the greatest common factor of x squared times y squared and x times y cubed is 45, then which of the following could y equal? So it tells us the greatest common factor of x squared times y squared and x times y cubed is equal to 45. Okay, so the first thing, well, if you're not familiar with factors, I'll briefly explain it. So a factor is a number that can be divided into another number and leave a whole number left over. So, for example, a factor of 6 would be equal to, a factor of 6 would be 2, 3, 1, or 6, right? Because if you take 6 and divide it by 2, you'll be left with 3, which is a whole number. If you take 6 and divide it by 1, you'll be left with 6, which is a whole number, etc., etc. Now, the greatest common factor is if you have two numbers, say 6 and 12, and the factors for 12 would be 1, 4, 3, 2, 6, and 12, because all these numbers can be divided into 12 and leave a whole number, and our factors for 6 would be 2, 3, 1, 6. The greatest common factor is, well, exactly that, the greatest common factor between the two. So the greatest factor in 12 that's also in 6 is 6. And that's basically what a greatest common factor is. So to do this problem right here, the first thing we want to do is factor whatever we can out of these two equations so we can find their greatest common factor. So what is common in x squared times y squared and x times y cubed? Well, in both of these we can pull out an x times y squared, right? Because that's common in both of them. This has an x squared and this has an x, so we can pull out an x. This has a y squared and a y cubed, so we can pull out a y cubed. So this will lead us to the greatest common factor, because this is the greatest common factor between these two things. So this will be equal to 45. And now there's a few ways we can go on from here. We can, well, the answer choices are 45, A is 45, B is 15, C is 9, D is 5, and E is 3. So it wants to know what could be the value of y. So if we plug in 45 for y, then we're going to get 45 squared, which is going to be a huge number, and it'll be way more than 45. So this can't be a number. 15 squared will be more than 45. 9 squared will be more than 45. 5 squared, well, if we have x times 5 squared, is equal to 45. And this will give us 25x, which will be equal to 45. But the question states that both x and y are positive integers, and an integer is a whole number. So there's nothing that we can plug in for x here that would give us a whole number to make this equation true. So it can't be x, because x here would be equal to a fraction. 45x would be equal to 45 over 25, and that's not a whole number. So by process of elimination, we can see that E is the only possible choice, because if we plug in 3, we would have x times 3 squared, which is 9. So we'd have 9x is equal to 45, and x could be equal to 5. The other way we could have done this is, say we could have did a factor tree for the number 45. We could have noticed that some factors of 45 are 9 and 5, and some factors of 5, well, that can't be broken down anymore. And there are factors of 5, but this is a prime number, and we want to get to prime numbers, prime factorization tree. The factors of 9 are 3 and 3. So the prime factorization of 45, if this is confusing you, you can just stick with this first part. But the prime factorization of 45 is 5 times 3 squared. And if we look back to our right here, the first thing we solve for, we can see that x fits into the 5 spot and 3 fits into the y spot. And that's the answer, 3. See you in the next video.